Bismillahirrahmanirrahim. In this lecture, I am solving problem 3.45 and 3.46 from the book Thermodynamics and Engineering Approach by CENGEL, 5th edition. So, problem 3.45 is saturated steam coming up the turbine of a steam power plant at 30 degrees centigrade condenses on the outside of a 3 centimeter outer diameter 35 millimeter long tube at a rate of 45 kilogram per hour. Determine the rate of heat transfer from the steam to cooling water. So here temperature is given to us, saturation temperature in given data, which is, this is problem 3-45 and this is given data. T is given to us 30 degrees centigrade and rate of mass transfer m dot of evaporation is given to us is 45 kilogram per hour, and convert this to 45 kilogram per second. So 45 divided by 3600 kilogram per second, which is equal to 0.0125 kilogram per second, and required is to find a rate of heat transfer, Q dot. Rate of heat transfer is basically Q dot. In solution, as we know that from the previous problem, that rate of mass transfer is equal to Q dot divided by latent heat of vaporization, HFG. HFG is the latent heat of vaporization. So first we find HFG. So from saturated steam table at temperature is equal to 30 degrees centigrade, HFG is equal to, so check this, this is saturated steam table and this is temperature 30 degrees and this is 30 degrees centigrade temperature and this is HFG. So HFG is here this value, this 2430.48 2430.8 kilojoule per kilogram. So we know m dot is equal to Q divided by HFG, and so Q is equal to m dot multiplied by HFG. M dot is equal to 0.0125 kilogram per second and HFG is equal to, this is 0.48, 2430.48 kilojoule per kilogram. This kilogram will be cancelled with kilogram, and joule per second is equal to watt. So 0.0125 multiplied by 2430.48 is equal to 30.385 kilo, and joule per second is equal to watt. So rate of heat transfer Q dot is equal to 30.385 kilowatt. Now problem 3.46. So statement is, the average atmospheric pressure at the neighbor elevation, at high elevation pressure decreases. So at high elevation atmospheric pressure is 83.4 kilopascal at elevation of 1610 meter. At elevation of 1610 meter, high elevation, atmospheric pressure is 83.4 kilopascal. So determine the temperature at which water is uncooled pair boils in the neighbor. It means that find the boiling temperature. Boiling temperature is basically saturation temperature. So find saturation temperature. So we will use a saturated steam table to find this value. So from saturated steam table at pressure is equal to 83.4 kilopascal. So 83.4 is not available in the steam table. So we will do interpolation. So pressure in kilopascal. So 75 kilopascal and 100 kilopascal is available, and we have to find temperature at 83.4, temperature in degree centigrade. So from this table, from the steam table, at pressure, this is pressure in kilopascal, this is 75 and 100, and 83.4 is not available. So at 75 degree centigrade boiling temperature is, yeah, our saturation temperature is 91.77, 91.77. At 83.4 this is required, and 100 kilopascal saturation temperature is 99.62, 99.62. So do interpolation to, so 100 minus 75, third value minus first value, divide by third value minus second value. Similarly, third value minus first value, divide by third value minus second value. So simplify this and find the value of saturation temperature, which is equal to 94.68 degree centigrade. So at high elevation of 1610 meter, the boiling temperature in an uncovered fan is 94.68 degree centigrade, and this is the end of the problems. So for more problems, please like and subscribe my YouTube channel and share with your friend. Thank you.